just we're gonna design for each segment, and we're gonna design the column. But before you do that, as I said, just actual force, 1.2 that 1.6 live road. So you could just double check the column reactions. So here, 6,000s. So here you just see that actual force diagram, right? At the bottom, 6,761 kips on the edge column, right? Maybe interior, let's see. The plan. Maybe 3D. In the prudent 3D, only just bottom floor. See that 12,000, right? So this is the ground floor or most bottom floor actual force. So you could use ETAPS to rotate down. But this is just one example at the most bottom floor. See the interior column has a 12,000 kips. Edge column and corner column has actual force 30,600 or 6,000. So those ETAPS you could use this actual. We could use do some rotate down and design the column, and by using steel design module and run it. Similar to it's almost identical, similar to the composite beam design. So let's see how the ETAPS choose sizes. This auto selection size has up to 14 by 500. Auto selection section, our property, so we should include the heavier sections. And because it has only up to 14 by 500, it showed a 1.12 state ratio. But since we are using the ETAPS 3D low tech down, we have to double check all the actual force, whether current actual force diagram or actual force are correct, right? But this is just one example that we're gonna try also column design using ETAPS. Again, I'm gonna turn off that. Go to frame sections, and I'm gonna import the heavier section of W14. And include those section to lateral column. Up. Lateral column, I include all 14 heavy sections. So I think that is a brief the answer to your questions.
Yeah.
Liam, so do you have any other questions? So is it clear, or you need some more explanation?
No, it's all clear. If we still don't understand the lateral design, I'll make sure I reach out to you. But I think you're going to be going over it in class on Thursday again, right?
Yeah, I'm gonna game. But I mean, I, I, I think everybody should understand this is quite advanced class. I mean, but I try to introduce as much possible. So again, and this is something that you're gonna learn or you study it. I think as far as if you guys actually at least listen and get familiar with all these tasks, and that will be your good foundation. I know that you cannot understand and learn every single one. There are, I think, more complicated features, but this is just general the building design procedure and just apps features. If you understand at least follow few overall, I think obviously it's gonna help to move on next. Uh, but those are all the tools. Those generally is tool that they have to learn and need time to really spend some time to play around. Similarly, maybe AutoCAD or Revit, because to me, right, AutoCAD and Revit, especially Revit, it's really hard to learn because there are too many features. The same thing that also tool need, obviously, that's some need time. Um, but I'm gonna go. I think more spend time on the retro system this coming Thursday. What I show you is something probably same. Uh, it depends on how you guys actually catch up, follow. Uh, but I think the retro system is more interesting uh, aspect that structural engineer really enjoy and learn. Um, so I think I'm gonna send this model, but whatever you model you created, I think you could just try out, spend some time, and try to uh, run it and fix. And also, I uploaded all the example file. You know, you maybe can download and run it, uh, and just play around. So let's see. Then Thursday. If you
Okay.
still have if you're having a problem, yeah, just shoot me the email, um, and then I could guide you.
Perfect. Thank you so
But
much,
from
Professor.
now on, the section property, or the wall thickness and beam size and column size, it still is much easy, right? So because we have a still data file, but ETABS, the concrete model, concrete, we don't have any standards, any sizes. So you have to define manually. But obviously, if you define a series of column and beams and wall thickness, I think you could use as a template, um, and you can just bring in from your other or previous ETAPS model to your new model. So it depends on how you manage. So I think the one thing that you're expecting, I'm expecting that current your project uh, it has a pretty also slender rectangular shape wall system. So 40-story tall, knowing that, I think you're gonna have a you need a secondary also support supplement lateral system. So you maybe have to choose moment frame or outrigger and belt truss like this, or exterior brace frame. You'll see that you obviously gonna uh, uh, find out. So obviously you need to fill it out. You have to, after you analyze it, you need to you're using some yeah this summary of drift deflections, so that you have to iterate a few times by changing up size as you size the wall thickness, and maybe change sizes by just strip down all the deflections. So this is an example that is how we size the wall. I mean, how we size the lateral system is we have to keep track down the overall deflection and interest drift. Every time you use size, I think you should split out the, the this drift deflection and then see whether those are less than the limit, and we'll keep by iterating we'll find out uh, workable lateral lateral elements, size and system. So this is something iteration we have to do it. So I think that's it. So just spend some time. I think I'm gonna send this model to you too anyway, but just try to learn and let's see. So this model, we haven't sized the wall, right, column yet. So the model just copy from your typical floor framing. So column size has to be done, and wall thickness and strength we have to do it. So I think maybe you could just while you're doing it, you try to set various concrete strengths, right? And you can maybe set your wall sections more, and then maybe coupling beam sections, so link beam. So for now we have just only one section. So this is the link beam sections. We have it, but obviously this link beam is as wide as wall. So when you create the wall thickness section properties, you have to create also this link beam associated with the link beam, as wide as wall thickness. So yeah, there are a couple of hands prep we needed. So once you add all the properties and we're gonna assign the wall thickness and we analyze we're running few iterations, and so I think that something that we have to do some fundamental studies. All days we don't have any ETABS model like this, ETABS software. So by hand calculation, I think I explained you. So those that hand calculation exercise also helpful to come up with overall lateral stiffness required. But here, maybe we just skip and we just run directly on a 3D model, but obviously these iteration procedures will improve much by using these other software. So I think we try to focus on a fundamental finite element model, but down the road we have to. I think you learn that this iteration is really time consuming and needs something better approaches.